In this orthokeratology case, the lenses are decentering nasally, and right now we're looking at the most recent design for the right eye. It's the same lens in both windows. I'll modify on this side, the right side, and we'll leave the left side open for reference. Whenever a lens is moving laterally, I look to first make sure we're using the largest lens we can, and we're already at 11.3 diameter. It was an 11.4 cornea, so we cannot go any larger without going to a semi-scleral design, which I'm not going to do here. What we can do is steepen the peripheral alignment of the lens so that it aligns a little bit better on the cornea. And then for this particular lens, I'm also going to reduce the size of the OZ. What that does is give us more lens to align peripherally, and that hopefully will give us improved centration of the lens. So if we look at the topography in the lower right corner here, we can see that there's an area of central steepening in the cornea, and I call this the corneal cap. It transitions from a steeper area to a flatter mid-periphery. And if we measure the size of this cap, it goes at about 4 millimeters superiorly, and then not very exact, but maybe 3.2 millimeters inferiorly. So at 7.2, it's a total diameter there of 7.2 millimeters. So if we cut that in half and go to the back surface curve, we can see right now the base curve extends out to a radius of about 4.5, and I would set that to around 3.6. That will still give us fairly good treatment and then give us more lens to use for alignment on the cornea. So right now it's at 4.5. We can decrease it by 0.9. So what I'm going to do is just drag the OZ and reduce it 0.9. It'll be 5.3. I'm keeping the lift the same, just changing the size of the zone. And then this one will go to 5.9. Okay, so we've shortened the OZ, and we have more lens available for alignment. By shortening the OC, we've increased the power of the lens, so we do need to decrease that and get back to our original target of 1.69. So I'm just going to click down here. Until we're as close to 1.69 as possible. And we're there. I'm going to go around to the different meridians and make sure they're all fairly close to target. And on some of these, especially this one, for example, I think we can be a little bit closer. So I'm going to go to 25% mode and drop this a little bit. That's a little better. Okay, so now we've got a smaller OZ, more lens aligning perfectly on the cornea for hopefully better centration. Now, does shortening the OZ cause any problems with glare or halos? Well, if we look at where this slope crosses the 20 micron line, it's at about 2.52 millimeters on the new lens. On the original lens, it crossed over at about 2.56 millimeters. So even though we shortened this OZ by almost 1 millimeter, we really didn't do much to change where this tear film surpasses 20 microns in depth. So if the patient did not have any issues with glare or halos before, I generally see that it doesn't become a problem. Um, so I'm not too worried about that. Now the second thing we'll do is steepen the periphery of the lens to get it to bear down slightly more on the peripheral cornea, and hopefully that will also improve the centration of the lens. I'm going to switch back to 100% mode. I noticed that this lens was initially designed in freeform mode. On a cornea that looks like this, where it's pretty regular, I would normally try a G-SYN lens, and I like to keep things just as simple as possible. Sometimes adding complexity to the lens makes troubleshooting difficult and makes the design process sometimes a little bit harder than it needs to be too. So I'm not going to switch it at this point because the lens was originally designed in freeform, but in a case like this, I think G-SYN would work very well. Along the same lines, I'm going to be making my changes in 100% mode. We're going to apply this change throughout the entire lens until proven that the patient really does need a more complex lens design where we're making meridian changes independent of other meridians. I just like to keep things as simple as possible. And so we're going to do everything in 100% mode. So when we're steepening the periphery of the cornea, or the lens rather, what I like to do is aim for about a 4 to 5 micron change. And what I mean by that is here we have about 2.8 microns of central clearance. So at most, I want to end up with about 7.8 microns of clearance. So I'm just going to come to the IC and click down about 4 times. And that puts us at about 7.7, so right under 7.8, and I think it's pretty reasonable. I would not do more than that unless something very unusual were happening with the lens. So I am going to go through the different meridians again and make sure nothing unusual happened. You can see a little bit of a kink in the tear film graph there and also there, so we're going to try to get rid of those. I'm going to reduce that steepening one click and see if it helps. Not really. Okay, so whenever this happens, what we have to do is go back to 25% mode and want to find out what's the smallest change we can make to this lens to get this graph to more of that usual parabola that we see. And sometimes this gets a little bit tricky. It's kind of trial and error until you find something that works. And these are not working that well. Okay, that looks a little bit more regular. And then I'm going to bring down the periphery of the lens. In the interest of time, it looks like this is, at least for now, the most aligned that I'm seeing. You can play around the control points. The idea is, again, to change what we did earlier to the lens as little as possible, but to keep a fairly regular shape to this return zone on the corneal graph. So I'm going to leave this lens design as it is now, and then I'm going to bring up the left eye. And then right now we're looking at the left eye. Again, it's the same lens in both eyes. And in this lens, or in this topography rather, you can see that the corneal cap here is noticeably larger than it is in the right eye. And if you run through the measurements, about 4.2, and 4.1, 4.2 there. And then we go here, we can see that we can't really shorten this OZ by very much. We want to extend the base curve out to about 4.2 millimeters, and we're out to maybe 4.4. So in this case, I probably would not shorten the OZ in this lens, but we'll steepen the periphery of the lens. Same thing, we're starting with about 1.7. So at most, I want to end up with 6.7 microns of clearance. 100% mode, I'm going to click down about 4 times. We're at 6.5, and I think that's a pretty good starting spot. So I'm going to go around, and again, make sure there are no unusual curves. The only one that looked a little bit off was this one. So we'll see, we can easily get rid of that, and that's not bad. I'll bring that, oops, sorry, wrong way. Okay, so we've got pretty good bearing peripherally. We've steepened the periphery of the lens, did not shorten the OZ, and putting this lens on the patient should result in a better centered post-wear topography. So there you have it, right and left eyes. Hope this helps out, and thanks for watching.